Okay, my name's Nicole, and this is a model of a cryogenic single-stage rocket. Cryogenic just meaning really cold. These elements boil at really low temperatures, so we have to keep them regulated at temperatures even below that because we want them in their liquid forms. Single stage just meaning there's only one reaction that occurs from launch pad into space. The space shuttle, for example, was a cryogenic single-stage rocket and used liquid hydrogen and liquid oxygen as its fuel and oxidizer component. We are just using a mixture of baking soda and water and vinegar to simulate this. So we have our two tanks with our liquids, and we have valves here. We open these, the reaction is allowed to occur in the tubing here, and in a real rocket they would also use things like valves and pumps to kind of speed up the flow of the liquids. In our model, we just have valves, so the reaction, we just allow gravity to push the liquids down. The reaction occurs with the baking soda and the vinegar. We get a lot of pressure out the bottom after the reaction, which produces a lot of energy. This is what propels our rocket up. In a real rocket, when the liquid hydrogen and liquid oxygen, for example, reaction occurs, that produces enough thrust to lift something like the space shuttle, or the Saturn V produces enough lift to get that from the launch pad into space. And so if we open our valves, all of this pressure that is generated from a reaction this is just what simulates the thrust that's created. In a real rocket using liquid hydrogen and liquid oxygen, the product of that reaction is just water vapor, but it produces enough energy and enough thrust to create enough lift for the rocket.